Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So, as starters, let me say that this report focuses on student study hours and apply hypothesis testing methods in business statistics to analyze it. So the first case study, we investigate whether the average study hours per day are significantly different from the expected 4 hours. The second case study, we compare the average study hours between female and male students to determine whether gender affects study behavior. This analysis helps educational institutions to understand student study patterns and also improve academic support. For the first case study, the topic is the statistical analysis of student study hours. The objective of this study is to determine whether the students' average study hours are significantly different from 4 hours. As we all know, we have to state two types of hypothesis, which is the null and the alternative. As for the null, we state that the average student study hours per day is 4 hours. As for the alternative, the average student study hours per day is not 4 hours. As for the type of the test, we choose one population mean Z test to analyze the data. The reason we choose the kind of test because there's only one sample is involved. The study tests a single mean, and the sample mean is compared with the hypothesis mean of 4 hours. The sample size for this study is 30 students.
Based on the case study that we conduct, these are the data that we collected. I'll be explaining about one population. For our first test, we wanted to challenge a common baseline benchmark. Do university students has the average 4 hours of studying per day? Our starting assumption, the null hypothesis, is that the average is exactly 4 hours. Our alternative hypothesis is simply that it's not 4 hours. Now, when we calculated the actual average of all 30 students combined, the result came out to 3.5 hours. On paper, 3.5 is obviously less than 4, but in statistics, a small difference can sometimes just be a fluke or a random coincidence. To prove if this 0.5 hour gap is a real trend, we use a tool called one population mean Z test. To run this test, we chose a standard 5% risk level, meaning we want to be 95% confident in our final decision. At this level, our statistical boundary lines are set at positive and negative 1.96. If our final calculated score lands outside these boundaries, it means the benchmark of 4 hours is officially debunked. After adjusting for the data's natural spread, we calculated our final test score known as the Z value. It came out to negative 1.98. Because negative 1.98 is past our boundary line of negative 1.96, it falls into the rejection zone. This proves mathematically that the 3.5 hour average isn't a random coincidence. Students are genuinely studying significantly less than the 4 hour benchmark.
Next, for the second case study, the topic is the comparative analysis between female and male students. The objective of this case study is to determine whether there is a significant difference in average study hours between female and male students. As we all know, hypothesis, we need to state two types of hypothesis, which is the null and the alternative. As for the null, we state that the mean study hours of female students are equal to male students. For the alternative hypothesis, the mean study hours of female students is different from male students. The type of test that we use to analyze this data is a t-test. The reason that we choose this test is there is two independent groups. The study compares to two means, and the population standard deviations are unknown, and the variance are not assumed to be equal. Therefore, t-test is the most suitable methods for this case.
Based on the case study that we conduct, these are the data that we collected. For this slide, I will explain the calculation for case study 2, which uses Welch t-test to compare the average study hours between female and male students. First, we state the hypothesis. The null hypothesis HO states that there is no significant difference in the average study hours between female and male students. The alternative hypothesis H1 states that there is significant difference in the average study hours between the two groups. Next, we move to step 1, which is calculating the sample means. For female students, the total study hour is 46 with sample size N1 equals 15. So the mean is 46 divided by 15, which give mean equals 3.0667. For male students, the total study hours is 59 with sample size N2 equals 15. So the mean is 59 divided by 15, which give mean equals 3.9333. This shows the male students have a slightly higher average study hours compared to female students. Now, step 2 is calculating the sample variances. For female students, after substituting the values into the variance formula, we get sample variance equals 1.6381. For male students, the variance calculated is sample variance equals 1.9238. These variances show the spread or variation of study hours in each group. Next, in Step 3, we compute the Welch-T statistic. We use the Welch-T test formula because the two groups may have unequal variances. After substituting all the values into the formula, the calculated t-value is negative 1.778. The negative sign only shows the direction of the difference, so we compare the absolute value, which is 1.78. Then, in step 4, we calculate the degrees of freedom using the Welch-Satterthwaite equation. After calculation, the degree of freedom is approximately 28. Finally, we make the decision. The significance level used is alpha equals 0.05 for a two-tailed test. The critical value from the t-table is plus or minus 2.048. Since the absolute t-value, which is 1.78, is smaller than 2.048, we fail to reject the null hypothesis. So, in conclusion, there is no significant difference in the average study hours between female and male students at the 5% significance level. For the interpretation, there is insufficient evidence to conclude that the average study hours per day between female and male students are significantly different at the 5% significance level. Although, male students recorded a slightly higher average study time, which is 3.9333 hours, compared to female students' 3.0667 hours. The difference is not statistically significant because the calculated p-value is 1.78, is less than the critical value 2.0482. Therefore, gender does not appear to have a significant effect on students' daily study hours.
To conclude, the result of both hypothesis tests shows that students generally study less than the expected 4 hours per day, indicating a need for better study management and academic support. However, the Welch-T test found no significant difference between female and male students' study hours, suggesting that gender does not significantly influence study duration. Overall, this finding demonstrates how business statistics can be used to analyze student study behavior and support educational decision-making. Based on the findings, several recommendations can be suggested. First, provide better time management programs, offer additional academic assistance, develop general support program instead of gender-based program, and lastly, encourage regular study routines among students. That's all for now. Thank you.